Hello everyone, I'm Associate Professor Maider Llaguno Munitxa here at UCLouvain in the Faculty of Architecture, Architectural Engineering and Urban Planning, also namely in LOCI, and the Louvain Institute of Landscape Architecture and Built Environment, also namely LAB. Within UCLouvain, I'm also part of the group Architecture Climat, together with Professor Sergio Altomonte, who is director of the group, and also the Dean of Research within the Institute Lab. And together we are part of the project MuSIC, which we very happily joined, given that it was following really the philosophy of Architecture Climat, where we focus on a very human-centered vision around questions related to the environment, at the building and also all the way to the city scales. And within MuSIC, as associated partners, we've been hosting PhD candidates from the Doctoral Network and Christos Grapas here sitting right next to me. He's right now with us at UCLouvain already for a few weeks, and he'll be staying with us for a duration of approximately 3 months, coming from the University of Perugia, and he'll be developing a fantastic and super interesting experimental campaign happening here in the streets of Brussels. I think it's best if you tell us about this interesting work.
Okay, so we are planning an experiment to understand better the differences of human environmental perception between day and night. So we know already from existing literature that fearful multisensory stimuli undergoes much more rapidly in comparison to happy stimuli. So in this context, we hypothesize that during nighttime, when safety concerns naturally increase, there will be a reflection of this phenomenon to the way that humans adapt to these multiple environmental urban stressors. So with our experiment in Brussels, we will monitor 24 people in terms of their physiology, but also complete environmental monitoring. We will ask them to walk around the city in the morning and also in the night. And we will monitor 3 main data. We'll make a collection of 3 main data categories, such as visual attention patterns using eye trackers. And also we'll use a wearable medical device measuring basic physiological data, such as heart rate variability or also electrodermal activity and skin temperature. And of course, we will do continuous monitoring in terms of all the environmental domains to assess their comfort. So we will monitor air quality, visual thermal, as well as acoustic comfort. And with this experiment, we aim to understand further 2 things. The first is the individual differences in adaptation patterns. And also we are aiming to assess how physiological indicators of stress are changing within, let's say, enduring diurnal multisensory conditions. So this is our experiment.